All right, so integration by parts, this is the very last part. I just didn't want to lump it with the first day because I felt like it was too overwhelming. So there's a last type for integration by parts, and you saw on the first day that there's certain types where you have to do integration by parts multiple times. And if you recognize one of those three formulas, then you use the tabular method. But there's one format where it is repeated parts, but tabular doesn't work. And it's in the format of e to the ax sine bx. A and b are just numbers, or e to the ax cosine bx. So what you specifically do here is integration by parts twice. So when you recognize it's one of these formulas, you have to do integration by parts twice. And then what you have, you're going to set it equal to the original integral and solve it like you're solving an equation. Just like back to algebra 1, when you were solving for x and you had x's on the left and x's on the right, you would get them all on one side and then get x by itself. It's the same concept here. All right, so we're only doing one of these. So you pick your u the same way using Lipit. So, and your dv would be everything else. So Lipit, there's no logs, there's no inverse trig, there's no polynomials. The next would be an exponential. Oh my gosh. This keeps doing this. Sorry, guys. That wasn't me. Let's see if we can go back. All right. Let me put something else under my mouse. Okay. Let's try this again. So your u is e to the 3x. Your dv is everything else. So it'd be sine 2x dx. Your du would be the derivative. So it'd be 3 e to the 3x. Your v would be the integral of sine, which would be, let's see, integral sine would be negative 1/2 cosine 2x. You have to really think backwards here, okay? Because technically you have a u here and your du is 2. You have to put a 2 in and a 1/2 on the outside. That's where the 1/2 comes from. All right, so the formula is u times v. So the formula is uv minus the integral of v du. So u times v, I would move any constants out in front. So u times v. So it's going to be negative 1/2 e to the 3x cosine 2x. That's u times v. Minus the integral of v times du. Pull that constant out. So you get a negative 1/2 and a 3. Comes out, becomes positive 3/2. So that's e to the 3x cosine 2x dx. Now, the problem you run into is you can't integrate this. You have to use parts again. So that means we're going to have our u, our du, our dv, and our v again. Okay, and so we're just looking at this integral. So you pick your u the same way with Lipit. Logs, no. Inverse trig, no. Polynomials, no. Exponentials, yes. So your u is e to the 3x. Our du is 3 to the 3x. Our dv would be cosine 2x. The integral of cosine 2x is 1/2 sine 2x. All right, so now what we're going to have is plus 3/2 times. So for this right here, we're doing this formula, uv minus the integral of v du. So u times v, I'm pulling the 1/2 out, so u, slow, okay, times v minus the integral of v times du. So pull that constant out. There's a 3 and a 1/2, so that would be 3/2 that's being pulled out. E to the 3x times sine 2x. Okay. So that was just this integral right here was replaced with this whole thing. Now I'm going to copy down the rest. So negative 1/2 e to the 3x cosine 2x. Okay, so now what we're going to do is distribute. So get rid of these parentheses by distributing this 3/2 to both. Okay, so we stop at integration by parts twice. And the reason being is, and I wonder if you notice this, if we try to integrate this again, it's the same as what we started with. You're just going to keep going back and forth between e to the 3x cosine 2x and e to the 3x sine 2x. So you stop integration by parts after doing it 2 times. And now I'm simplifying. I'm distributing the 3/2. Would be negative 9/4 the integral of e to the 3x sine 2x. And then what we're going to do is we did integration by parts twice. Now we're going to set it equal to the original integral. Here's the original integral. So we're going to set it equal to the integral of e to the 3x sine 2x dx. All right, now, just like I said earlier, and just like we did in Algebra 1, what are we solving for? We're solving for what this integral equals. Well, you have that integral on both sides. So you got to get it all to one side. So I'm technically going to add 9/4 to over here, which is really 4/4 because it's just 1. So if I add 9/4 over, I'm going to have 13/4 the integral of e to the 3x sine 2x dx equals these two terms here, okay, because I move this to the other side. So negative 1/2 e to the 3x cosine 2x plus 3/4 sine 2x. All right, and then we want to get this integral by itself, so we are going to multiply everything by 4/13 to clear that fraction. So that means on the left here, we have the integral of e to the 3x sine 2x, which is what we're trying to solve for. We want to know what this integral equals. Okay, and now I'm going to distribute this 4/13 to both parts. So this ends up reducing to negative 2/13 e to the 3x cosine 2x, and then plus 3/4 times 4/13 ends up being 3/13 e to the 3x sine 2x plus c. All right, and here is the final answer. Cut through that a little bit. Terrible drawing boxes, sorry guys. But there you go, and you just have to recognize these two formats. Recognize that, all right, this is repeated parts. Tabular won't work because if I try to make my U and dV chart and I pick my U as e to the 3x based on lipid, you're supposed to derive until you get down to what? Until you get down to 0. E to the 3x will never derive down to 0. So that's why tabular doesn't work. So you have to specifically do integration by parts twice, set it equal to the original integral, and then solve for that original integral. All right, there you go.